Hey everyone! Today we're going to explore a NodeJS script that showcases how to interact with a MySQL database. This script is particularly useful because it demonstrates how to perform common database operations such as inserting, selecting, updating, and deleting records, all within the context of a NodeJS application. Imagine you're building a web application that needs to store client information in a database. This script serves as a guide on how to connect to a MySQL database, create a table to store client data, insert new clients, retrieve clients based on their email addresses, update client information, and even delete clients when needed. Understanding how to work with databases is crucial for any aspiring programmer, as it opens up a world of possibilities for building dynamic and data-driven applications. So, without further ado, let's dive into the code and see how it all comes together. Now let's dive into the code. All right, let's break down the code step by step to understand what's happening and why. Firstly, we import the MySQL module, which allows us to interact with MySQL databases in our NodeJS application. This module provides various functions to execute SQL queries and manage database connections. Next, we define a function named connectToDatabase, responsible for establishing a connection to the MySQL database. This function takes no arguments and returns a connection object. It's crucial to create a reusable function for connecting to the database, as it helps in managing connections efficiently and reduces code duplication. Moving on, we have a function called insertClient, which inserts a new record into the client's table in the database. This function takes 4 parameters: first name, last name, email, and telephone, representing the client's details. Inside this function, we construct an SQL insert query with variable binding to prevent SQL injection attacks. Once the query is executed successfully, the function returns the ID of the newly inserted record. Next, we have the selectClientByMail function, which retrieves a client's information based on their email address. This function takes the email address as a parameter and constructs an SQL select query to fetch the corresponding client record from the client's table. The result is then returned to the caller. Moving forward, we encounter the updateClientEmail function, responsible for updating a client's email address in the database. This function takes 2 parameters: client ID and new email. It constructs an SQL update query to modify the email address of the client with the specified client ID. After executing the query, the function returns the number of affected rows. Lastly, we have the deleteClientById function, which deletes a client record from the database based on the provided client ID. Similar to previous functions, it constructs an SQL delete query to remove the client record from the client's table. After executing the query, the function returns the number of affected rows. Overall, this script demonstrates the fundamental principles of CRUD, create, read, update, delete operations in MySQL databases within a NodeJS environment. It provides a robust foundation for building applications that require interaction with a MySQL database. In conclusion, understanding how to interact with databases using NodeJS and MySQL is essential for building robust and efficient web applications. The code we've explored today serves as a foundational piece for managing database operations seamlessly within a Node.js environment. By encapsulating database connectivity and CRUD operations into reusable functions, we promote extensibility and maintainability in our codebase. This means that as our application grows, we can easily incorporate additional database functionality without repeating code or introducing unnecessary complexity. Moreover, by adhering to JavaScript best practices and principles such as modularization and asynchronous programming, we ensure that our code is not only efficient, but also scalable. Leveraging modern JavaScript technologies allows us to harness the full power of Node.js while maintaining a clean and organized codebase. In real-world applications, this code can be integrated into various components, such as user authentication systems, content management platforms, or e-commerce websites, where persistent data storage and retrieval are paramount. By implementing these database interactions in a structured and reusable manner, we lay a solid foundation for building complex and feature-rich applications. Thanks for watching, everyone, and don't worry if you missed anything. We've added a link to the source code in the description. If you found this video helpful, please like and subscribe for more of the same. Thanks again, and remember, we're always learning, so keep coding and keep exploring.